November 17, 2022. 0243 hours. Kyiv, Ukraine. Air raid sirens activate across the capital. Russian forces launch coordinated missile strike. Kaliber cruise missiles from Black Sea. Kh-101 cruise missiles from strategic bombers. Shahed's drones mixed in for saturation. Total: 18 incoming threats targeting critical infrastructure and government buildings. Ukrainian air defense responds. S-300 systems engage at long range. IRIS-T systems provide medium-range coverage. And protecting the most critical sectors. NASAMS. Norwegian Advanced Surface-to-Air Missile System. American-Norwegian collaboration. Delivered to Ukraine just weeks earlier. Untested in Ukrainian hands. Unknown performance against Russian saturation attacks. Over the next 12 minutes, NASAMS engages 6 targets assigned to its sector. Fires 12 AIM-120 AMRAAM missiles. All 6 threats destroyed. 100% success rate. 0 targets penetrate NASAMS coverage zone. The capital's most defended areas remain untouched. This isn't isolated success. This is pattern. NASAMS in Ukraine achieves something military analysts consider nearly impossible: perfect interception rate. Month after month. Attack after attack. 100%. But whether this perfection is sustainable, or whether it's success built on factors that can't last, determines if NASAMS truly changed air defense, or if it's just one good run before inevitable failure. This is Military Report, where we analyze the battles that change wars. NASAMS, National Advanced Surface-to-Air Missile System, developed by Kongsberg Defence and Aerospace, Norway, and Raytheon, USA. First deployed 1998. In service with Norway, USA, protecting Washington, D.C., Netherlands, Spain, Finland, Lithuania, Indonesia, Qatar, Ukraine. System components: Fire Distribution Center, FDC. Battle Management System. Coordinates multiple launchers. Integrates with sensors. Prioritizes targets. Allocates missiles. Central brain of system. AN-MPQ-64, Sentinel radar, X-band 3D radar. Detection range 75+ kilometers. Tracks 60+ targets simultaneously. Provides targeting data. Can cue missiles from multiple launchers. Launchers, typically 3 per battery. Each launcher holds 6 missile canisters. 18 missiles ready to fire per battery. Reload time significant but manageable. Missiles: AIM-120 AMRAAM, Advanced Medium Range Air-to-Air Missile. Same missile used by F-16, F-22, F-35. Active radar guidance. Fire and forget. Range 30-50 km against aerial targets depending on variant. Speed Mach 4. Originally designed for air-to-air combat. Adapted for surface-to-air role in NASAMS. Additional sensors can integrate AWACS data. Ground-based radars. Other air defense systems. NASAMS is designed for network-centric operations. The integration capability matters enormously. Cost: complete battery, $180, 250 million, single AMRAAM missile, 1.5 million, radar, 25-35 million, FDC, 15-20 million USA delivered to Ukraine, initially 2 batteries, November 2022, later 4 more batteries through 2023. Total 6 batteries operational. Plus ammunition, hundreds of AMRAAM missiles. Exact numbers classified but sufficient for sustained operations. Ukrainian deployment, protecting Kyiv primarily. Also some coverage for other critical infrastructure. Strategic assets. Government facilities. Power stations. The most valuable targets get NASAMS protection. Everything else relies on older Soviet systems or other Western systems like IRIS-T. November 2022 through March 2024, NASAMS in Ukraine achieves documented 100% interception rate in its assigned sectors. Every target engaged is destroyed. 0 confirmed failures. 0 penetrations. Perfect defensive record. This is extraordinary. Air defense systems typically achieve 60-80% success rate against modern threats. 90% is considered excellent. 100% sustained over months of combat. unprecedented in modern warfare. Either NASAMS is revolutionary, or something else is happening that explains the perfection. 3 questions. We'll answer them at the end. Is NASAMS truly superior technology achieving impossible perfection, or are other factors creating 100% success rate that wouldn't replicate in different circumstances? Can Ukraine sustain NASAMS operations long-term given expensive ammunition and limited interceptor inventory, or is this short-term success? And the critical one, does 100% interception rate prove air defense has decisive advantage over modern aerial threats? Or is NASAMS succeeding only because Russia isn't employing its full capabilities against protected sectors? The official Western narrative celebrates American-Norwegian technology excellence, superior engineering, validation of NATO systems. All partially true, but incomplete. The Russian narrative dismisses or ignores, doesn't publicize NASAMS success, doesn't acknowledge failure to penetrate, shifts attacks to areas without NASAMS coverage. The absence of Russian commentary is itself revealing, because NASAMS success isn't just about the system. It's about how Ukraine employs it, how Russia responds to it, and what both sides aren't saying about this perfect defensive record. Let's examine what NASAMS actually does differently from other air defense systems. Factor 1. Missile quality. AMRAAM AMRAAM is one of world's best air-to-air missiles, designed to shoot down maneuvering fighter jets. Cruise missiles and drones are comparatively easy targets. No evasive maneuvers, predictable flight paths. The missile is overqualified for the threats it faces. This matters. Factor 2. Fire control sophistication. NASAMS FDC uses advanced algorithms, tracks all targets in area, calculates optimal engagement sequence, assigns missiles efficiently, avoids wasting interceptors. The automation and integration enable better decisions. Factor 3. Network integration. NASAMS receives data from multiple sources. Ukrainian long-range radars, AWACS if available, other air defense systems. The data fusion creates comprehensive air picture. NASAMS engages with better information than standalone system would have. Factor 4. Selective engagement. This is critical. NASAMS doesn't engage everything. Only targets within its sector. Only targets penetrating to certain depth. Other air defense systems, S-300, IRIS-T, MAN-PADS, handle other threats. NASAMS gets the critical targets after other systems have taken first shots. The success rate is partially because target set is pre-filtered. Factor 5. Limited coverage area. NASAMS protects specific locations. Maybe 10-20% of Kyiv airspace. Critical government areas. Key infrastructure. Russian missiles targeting other parts of city are engaged by different systems. NASAMS' 100% success is within limited operational envelope, not citywide coverage. Factor 6. Operator selection and training. Ukrainian crews operating NASAMS are best personnel available. Selected. Trained by Americans and Norwegians. Motivated. Experienced with air defense from Soviet systems. The human factor in success is significant. Factor 7. Ammunition availability. USA provides AMRAAM missiles. Ukraine isn't constrained by interceptor shortage for NASAMS specifically. Can fire multiple missiles per target without worrying about inventory depletion. The resource availability enables optimal employment tactics. Combined, NASAMS achieves 100% success because excellent technology, plus excellent training, plus excellent integration, plus selective employment, plus adequate ammunition fosters optimal conditions for air defense. The perfection isn't magic. It's engineering and operational art working together. Stay with me. What happens when we examine individual engagements reveals why 100% rate is both impressive and less remarkable than it appears. The truth is in the details. Typical NASAMS engagement sequence. Stage 1. Detection. Ukrainian early warning radars detect launch of Russian missiles. Range. 400+ kilometers if using long-range systems. Provides several minutes warning. NASAMS FDC receives alert. Begins tracking potential targets. Stage 2, track development. As missiles approach, NASAMS' own Sentinel radar acquires targets. Tracks trajectory. Calculates projected path. Identifies which targets are threats to protected area, those passing by. The discrimination is automatic. Stage 3, target prioritization. FDC determines engagement order. High-value targets first. Threats closest to impact. Coordinates with other air defense systems to avoid duplicate engagements. Allocates missiles, usually 2 per target to ensure kill. Sometimes 1 if confidence is high and ammunition must be conserved. Stage 4, launch. AMRAAM launches from canister. Boosts to speed. Radar guides it to target area using mid-course guidance. As missile approaches target, active seeker activates. Missile independently locks onto target. Fire and forget allows engaging multiple targets rapidly. Stage 5, intercept AMRAAM maneuvers to impact. Hit to kill or proximity fuse depending on variant. Target destroyed. Debris falls. FDC confirms kill through radar track termination or visual confirmation. Ready for next engagement if needed. Typical time from detection to intercept, 2-5 minutes depending on range. NASAMS can handle 6 to 10 targets per battery depending on configuration. Reload time for launchers, 30-60 minutes. Not instant, but manageable between attack waves. Real engagement example, reconstructed from available information. December 2022 attack, Russian forces launch combined strike. 8 caliber cruise missiles, plus 12 Shahed drones. Targeting Kyiv government district and power infrastructure. Ukrainian response. S-300 systems engage at long range. Intercept 3 caliber, 4 Shaheds. Iris-T systems engage at medium range. Intercept 2 caliber, 5 Shaheds. NASAMS assigned 3 remaining caliber targeting most critical facilities. NASAMS engagement. Detection, all 3 threats tracked. Priority, all equal priority, government targets. Allocation, 2 missiles per target, 6 missiles total. Launch, ripple fire from 2 launchers. Result, all 3 caliber destroyed. 0 penetrations. The 100% success for NASAMS. But context matters. NASAMS engaged 3 of 20 total threats. Other systems handled the rest with mixed success. NASAMS got the critical targets and performed perfectly, but wasn't defending entire airspace alone. This pattern repeats. NASAMS consistently achieves 100% within its assigned role. The role is carefully scoped to enable success. The perfection is real, but contextualized. This is military report. Real tactics. Real consequences. Cost implications of 100% success. Engagement costs. NASAMS fires average 2. AMRAAM per target. Doctrine for high-value targets. AMRAAM costs $1.2 million, estimate for current production. Cost per successful intercept, $2.4 million average Russian weapons being intercepted. Caliber cruise missile, $1.2 million, H1 cruise missile. 8-13 million. Shahed drone, $20,000 $50,000 cost exchange ratio against Kyiv, roughly equal 1.1. Against Kyiv, favorable to defense, 1.3 to 1.5. Against Shahed, unfavorable to defense, 50.1 to 121. This creates economic problem. Using $2.4 million defense to stop $30,000 drone is unsustainable. NASAMS is so valuable that Ukraine reserves it for cruise missiles and critical threats. Cheaper systems and even small arms handle Shaheds when possible. The resource allocation is critical strategic decision. November 2022 through February 2024 estimated totals. NASAMS engagements, 60-100 targets, exact number classified. AMRAAM missiles fired, 100-200, 2 per target average. Success rate, 100%. All targets destroyed. Cost of interceptors, $145-240 million value of targets destroyed. $200-800 million depending on Russian weapon mix. From pure cost perspective, marginally favorable to unfavorable depending on target mix. But strategic value of protecting government district and critical infrastructure far exceeds cost. The investment is justified by what's protected, not cost exchange arithmetic alone. Sustainability question: can Ukraine maintain this indefinitely? Factor 1. Ammunition supply. USA has produced 15,000 plus AMRAAM since program began. Current production, several hundred per year. Ukraine's consumption, perhaps 100-200 per year for NASAMS. Supply currently exceeds demand. Sustainable if USA continues providing? Factor 2. System maintenance. NASAMS requires maintenance. Radars, launchers, fire control systems. Norwegian-American technical support continues. Spare parts available. System reliability remains high. Sustainable with continued support. Factor 3. Operator training. Initial crews trained. Additional crews training for expanded batteries. Training pipeline established. Sustainable. Factor 4. Russian adaptation. Russia shifts tactics. Reduces caliber Kh-101 strikes on Kyiv. Increases Shahed saturation attacks on undefended areas. Still strikes Kyiv occasionally, but less frequently. The threat evolution changes calculus. Assessment. NASAMS operations are sustainable with continued Western support. Without external ammunition supply, unsustainable. The dependence on American resupply is strategic vulnerability. But as long as support continues, NASAMS can maintain operations and effectiveness. This is Military Report, where we break down the battles that change wars. Why doesn't Russia overwhelm NASAMS? Option 1. Saturation. Launch 50 plus missiles simultaneously at Kyiv. NASAMS can only engage 1836 threats per battery, depending on launchers available. Saturation would overwhelm. Russia has capability to do this, but hasn't. Why? Reason: cost. Russia doesn't have unlimited caliber and Kh-101 inventory. Production is limited. Each missile is expensive. Expending 50 cruise missiles to guarantee penetration of NASAMS zone is possible, but economically ruinous. Russia preserves inventory for more certain targets or spreads attacks across Ukraine, where air defense is weaker. Option 2. Decoys. Mix real missiles with cheap decoys. Force NASAMS to engage everything. Exhaust interceptor inventory. Russia attempts this with Shaheds, which are partly decoys, partly real threats. Partially effective in drawing fire from other systems. But NASAMS typically doesn't waste AMRAAMs on Shaheds unless absolutely necessary. Option 3. Low-altitude approach. Fly cruise missiles very low to reduce detection range. Complicate intercept geometry. Russia does attempt this. NASAMS still intercepts successfully because AMRAAM is very capable against low-altitude targets and radar coverage is good enough. Option 4. Hypersonic weapons. Use Kinjal or other high-speed weapons. NASAMS is designed for aircraft and cruise missiles, not hypersonic ballistic missiles. Russia has used Kinjal occasionally, but not saturating Kyiv with them, either due to limited inventory or political/military decision to preserve these weapons. Option 5. Electronic warfare. Jam NASAMS radar. Spoof GPS. Disrupt communications. Russia certainly attempts EW. NASAMS is designed to be jam-resistant. Frequency hopping radar. Encrypted communications. Link redundancy. EW helps marginally but doesn't defeat system. Option 6. Accept inefficiency. Don't try to overwhelm NASAMS directly. Strike other Ukrainian cities without NASAMS coverage. Accept that Kyiv government district is too well defended. Strike infrastructure in less protected areas. Russia largely adopts this approach. NASAMS succeeds partly because Russia stops seriously contesting the areas it protects. Russian adaptation to NASAMS presence. Strike around it, not through it. The success creates deterrence. Russia knows NASAMS zones are deadly. Avoids them. This is strategic effect beyond simple interception count. Which factor explains NASAMS 100% success most? A. Superior technology. B. Selective employment. C. Russian target avoidance. The answer reveals whether success is replicable elsewhere. Keep watching. Comparative analysis, NASAMS versus other Ukrainian air defense, S-300 Soviet-era long-range system. Success rate 50–70% estimated. Older technology. Limited maintenance. Depleting interceptor inventory. Covers large areas but less effectively than NASAMS. IRIS-T SLM, German system. Modern. Excellent performance. Success rate 90–95% estimated. More limited inventory than NASAMS. Covers different areas. Also very effective but smaller scale. Patriot PASC-3, American. Most sophisticated Ukrainian air defense. Success rate 95–100% against targets engaged, including Kinzhal hypersonic missiles. But very expensive interceptors, $4–6 million each. Used only for highest value threats. More capable than NASAMS against some targets, but less numerous. NASAMS occupies sweet spot, modern and effective. Reasonably cost-effective. Available in meaningful numbers. Good integration. Reliable performance. Not the absolute best at any single thing, but excellent overall balance. Lessons from NASAMS success. Lesson 1. Integration matters. NASAMS success depends heavily on integration with other systems. Receives early warning from long-range radars. Coordinates with S-300, IRIS-T, Patriot. The network effect multiplies individual system capability. Air defense is system of systems, not standalone platforms. Lesson 2. Modern missiles work. AMRAAM performs as advertised. High reliability. Difficult for targets to evade. The technology advantage matters. Western precision and reliability translates to operational success. Lesson 3. Selective employment enables perfection. NASAMS doesn't try to do everything. Protects specific areas. Engages specific targets. The limited scope allows concentration of resources where they matter most. Attempting 100% coverage of everything would dilute effectiveness and fail. Lesson 4. Training quality matters. Ukrainian NASAMS crews are well-trained and motivated. Technology alone insufficient. Human operators making correct decisions under pressure are essential. The investment in training is as important as hardware investment. Lesson 5. Sustainability requires external support. Ukraine cannot maintain NASAMS operations alone. Depends on American ammunition. Norwegian-American maintenance support. Training infrastructure. The system works because Alliance provides necessary support continuously. Lesson 6. Deterrence from capability. Russian targeting shifts away from well-defended areas. NASAMS creates zones Russia avoids rather than tests. The deterrent effect is strategic success beyond intercept statistics. Lesson 7. No perfect defense exists. NASAMS protects limited areas. Rest of Ukraine still vulnerable. Perfect local defense doesn't equal perfect national defense. Air defense requires layering, prioritization, and accepting some areas remain vulnerable. Let's answer the 3 questions now. Is NASAMS truly superior technology achieving impossible perfection, or are other factors creating 100% success rate? Both. NASAMS is excellent technology. AMRAAM is among world's best air-to-air missiles. Radar and fire control are sophisticated. Training is excellent. But technology alone doesn't explain 100%. Other factors. Integration with other air defense systems creates layered defense. NASAMS engages threats after other systems have thinned the attack. Selective employment means NASAMS only engages targets within its coverage zone and priority level, not defending everything. Adequate ammunition supply from USA enables firing multiple missiles per target without resource constraints. Russian targets avoid heavily defended areas once they recognize NASAMS' presence. The success creates deterrence, reducing future attacks. Perfect storm of good technology. T. Good training. Good employment, adequate resources, enemy adaptation, 100% success. Remove any factor and perfection becomes unlikely. The success is real but contextual. Not replicable everywhere under all conditions. But genuine achievement nonetheless. Can Ukraine sustain NASAMS operations long-term given costs and inventory limits? Yes, with continued Western support. No, if left alone. AMRAAM consumption rate, 100-200 per year estimated for current operations. USA production, several hundred per year. Surplus exists. Supply can meet demand as long as political will continues. System maintenance requires external technical support. Norway and USA providing this? Sustainable as long as alliance commitment remains. Operator training pipeline established. Additional crews being trained for expanded batteries. Sustainable. But Ukraine depends completely on external supply. Cannot produce AMRAAM domestically. Cannot maintain systems without foreign expertise. The strategic vulnerability is dependence. Any disruption to supply chain degrades NASAMS capability rapidly. Long-term sustainability requires continued Western political support, continued ammunition production and delivery, continued maintenance assistance. If any component fails, NASAMS effectiveness degrades. The success is sustained by alliance commitment, not Ukrainian self-sufficiency. And the critical question, does 100% interception rate prove air defense has decisive advantage, or is NASAMS succeeding only because Russia isn't employing full capabilities? NASAMS succeeds within specific context, not universal proof of defensive advantage. Russia could overwhelm NASAMS with massive saturation attack, 50+ missiles simultaneously, hypersonic weapon saturation, sustained campaign accepting high costs. Russia chooses not to because cost is prohibitive relative to value of targets. Missile inventory is limited and must be conserved. Other targets in Ukraine are easier and still strategically valuable. NASAMS defended areas aren't worth the resource expenditure to penetrate. This means NASAMS creates effective deterrence through costly exchange ratio. Russia can penetrate if willing to pay the price. Chooses not to. The defensive success is real, but not absolute. It's cost-benefit analysis favoring defense within limited scope. Against different opponent, one with unlimited resources or different priorities, NASAMS might not achieve 100%. The success reflects both system capability and Russian cost-benefit calculations. Overall, NASAMS proves modern air defense can be highly effective when well-integrated, well-supported, and defending limited high-value areas. Does not prove air defense has universal advantage over offense. Context matters enormously. The quiz answer, which factor explains NASAMS 100% success most? B. Selective employment. 40-50% of explanation. Superior technology matters. But many excellent air defense systems achieve 70-80% success rates. The difference between 80% and 100% is primarily selective employment. NASAMS doesn't attempt to defend all of Kyiv, doesn't engage all threats, defends specific zones, engages specific high-value targets. The scoped mission enables concentration of resources, perfect execution within defined limits rather than imperfect execution across unlimited scope. Without selective employment, if NASAMS tried to defend everything against everything, success rate would likely drop to 80-90%. Still excellent, but not perfect. The operational art of defining achievable mission is as important as technology quality. This is Military Report. Subscribe to Military Report, because preparation defeats improvisation. November 2022 through March 2024. NASAMS in Ukraine summary. Batteries deployed, 6 total coverage. Kyiv government district and select critical infrastructure, approximately 10-20% of capital area. Engagements, 60-100 targets estimated missiles fired. 120-200 AMRAAM, estimated success rate 100% within assigned sector's cost, $145-240 million in ammunition plus initial system costs. Strategic effect, Kyiv government district remains functional. Critical infrastructure protected. Russian targeting. Lessons for military forces worldwide. Modern Western air defense systems can achieve very high success rates Integration and networking multiply effectiveness. Selective employment enables perfection where universal coverage cannot. Training quality is as important as technology quality. Economic sustainability requires external support or domestic production. Defensive success can create deterrence effect beyond intercept numbers, implications for future warfare. Air defense is viable against subsonic cruise missiles and drones. Networked systems outperform standalone systems significantly. Perfect local defense is achievable, but requires resource. Concentration, cost per intercept must be considered in system selection and employment. Sustained operations require reliable supply chain. No system provides universal protection against all threats. Was NASAMS deployment strategically successful? Absolutely. Achieved mission of protecting critical Kyiv assets, maintained 100% success rate, created deterrent effect, justified cost through protection of irreplaceable strategic targets, success enabled by alliance support, but success nonetheless. What would you have done differently? As Ukraine, request more NASAMS batteries earlier, expand coverage, train more crews. As USA, deliver more systems faster. Increase AMRAAM. As Russia, either accept NASAMS zones are too costly to attack and focus elsewhere, or commit resources to saturation attacks accepting high costs. The Norwegian-American system that achieved perfection. The air defense that never failed. The success that comes with asterisks and context, but remains genuine achievement. 100% interception rate. In war. Against a capable adversary. Over 16 months of continuous operations. The record speaks for itself. Even if the record exists within carefully defined scope. Even if success depends on continued external support. Even if perfection isn't universal or permanent. This is Military Report. Subscribe. Because we break down the battles that textbooks will study for decades. Perfect defense. Limited scope. Strategic context. And the uncomfortable truth that success in one place requires vulnerability elsewhere because resources are finite. 100% isn't 100% of everything. Just 100% of what was attempted. And what was attempted was chosen carefully to be achievable. That's not criticism. That's operational art. Defining the possible. Achieving the defined. Succeeding where success matters most. The capital stands. The government functions, the defense held, and the NASAMS record remains perfect. Stay vigilant.